Very good morning, my dear students. Okay, we have been discussing about control charts and we have started with control charts for variables. And yesterday we were discussing about a certain numerical, wherein we were trying to find out or trying to establish the control limits. Okay, so now let me see, because I might have left it in the half or at the final stage. Let me recapitulate and then again see how it works. So already the problem has been dictated. I'll just put the values over here. Central line, for X bar chart, upper control limit X bar, central line of X bar, lower control limit of X bar chart, upper control limit of R chart, central line of R chart, lower control limit of R chart. Okay, I'll first write down the equations over here. This one is D4 R bar. This is central line is R bar. Lower control limit for the R chart is D3 R bar, where D4 and D3 are the factors which will depend on the sample size. Okay, in this particular problem, the sample size given here is n is equal to 4 and number of subgroups given were 20. And in fact, we were given the value of sigma x bar and sigma r bar, so it was very easy to find out, not that much difficult, and it was found out, the x double bar values and other things were found out. Okay, I am just writing down the equation for this one and I am explaining about this. And here, the upper control limit for X bar chart, it is estimated from R bar. Okay, actually the upper control limit for X bar chart would have been X double bar plus 3 sigma X bar, but we know that this 3 sigma X bar can be found out by using the R bar itself. So upper control limit is going to be X double bar plus E2 R bar, because the sigma X bar is being estimated from R bar. It is as simple as that, because R bar already we can find out this one. And central line for X bar chart is X double bar. Lower control limit for X bar is X double bar minus E2 R bar. And as I told you, this E2, D4 and D3, they will depend only on the subgroup size, or it is also called as the sample size 4. And for that one, we need to refer the relevant, I repeat again, the relevant statistical tables. Here, the table B or C, whatever the statistical tables are provided to you, in table number B and C, you can get these things. Okay. Table C, you can get A2 values as well as D4 and D3 values. And in that table, you can observe that the D3 up to subgroup size 6, D3 is going to be 0. That means the lower control limit for R chart or the range chart is 0. Upper control limit is going to be the different values. So D4 values will be given up to the sample size 6. D3 is going to be 0, and D4 here in this case for the sample size 4 is 2.28, and that means it might be given. That means D4 is equal to 2.28 and A2 values for sample size 4, this one is given as 0.73. So we can find out these things. R bar values we can find out. and these things we will find out, and the relevant upper control limit and the lower control limits can be found out in this particular way. And if we have to represent them, I'll try to give you the value. Here, after finding out all these things, R bar, and because I'll mention R bar is 0.169. How do we find out the R bar? Because sigma R is known, sigma R divided by 20, number of subgroups, so it will give you this one, the R bar. And X bar, X double bar can be found out because sigma X bar is given, and we know the number of subgroups as 20, hence the X double bar is equal to sigma X bar divided by 20, so which works out to be 20.64. 20.6415. And by knowing R bar and multiplying it by E2, that is 0.73, we will find out the upper control limit of X bar chart. So total value it works out to be, the total value is, it is going to work out to be 20.7645. And lower control limit, it works out to be 20.5185. And similarly for upper control limit for R chart, it works out to be, because D4 is 2.28 multiplied by 0.169, so it works out to be 0.3853, and the lower control limit is 0. What does it mean? Now these values have been established, upper control limit and lower control limit have been established, and if we have to draw the chart will be drawn like this. This is for X bar chart. Along the x-axis, we are going to represent the samples which are taken in the chronological order, like first sample, second sample, third sample, fourth sample, fifth, like that. And along the y-axis, here, since it is X bar chart, for each sample I am going to mention its values. So it might be 20, 19.5, 20.1, 20.3, like that. It is going to come up like this. Maybe the next example it will make it more clearer. I am just giving you, try to give you certain idea about that. So along this one, we are going to mention the values of X bar. For each sample, the different values are going to be different, or it might be same. But since we say that there is going to be a variation, variation is inevitable, their values are not going to be the same. Okay? So it is going to be like this. It has got a variation. Now that variation, what I want, that variation has to be between these two limits. Let me say that this is the upper control limit, and I told you upper control limit is represented by a dash line. So this upper control limit of X bar, this is going to be 20.7645 mm. And the central line, I am going to put it over here, which is represented by the solid line. Try to understand here, upper control limit and the lower control limit, they are equidistant from the central line, because here you can observe this one. This is plus or minus A2 R bar. This is true. Okay, that is what you need to think about it. In case of R chart, it may not be. Okay, it may not be. That is what we need to understand. But in case of X bar chart, it is never called as X chart. It is called as X bar chart. And here I am going to represent this lower control limit as dashed lines. So this one is LCL. L lower, C control limit, L x bar. This is equal to 20.5185. And the central line of x bar chart is 20.6415. That is how you need to represent. Because these things have been established. Now suppose after the process, the next sample when you take it and try to plot it. So what are the possible things it might happen? It may fall exactly here. For example, it might fall exactly here. Or it might fall on this, or it might fall on this, or it might fall here, or it might fall here, or it might fall beyond this, or it may fall below this thing. These are the possible cases. If they are falling within the upper and lower control limits, then we say that the process is under control and it has got the natural, even though variation, they should not have variation, it should be exactly on x double bar, but it has got certain variation. That is why that allowed variation, it is happening. That is what we say. If it is between, as long as between these two control limits, a point falling on the upper control limit or point falling on the lower control limit, they are also within the limits. That is what we can understand. The moment it falls outside, then we say that the process is not under control, because no longer it is the natural variation. The variation is because of certain assignable reasons. Hence, the process needs to be stopped and the investigation is to be carried out. That is what it means. Okay. Similarly, for R chart, we will draw it just below it. Just below the X bar chart, the R chart will be drawn. Here also, we are going to take the same sample. Sample sizes and other things remains the same. That is why it has to be drawn below this one. This is the sample number. And these are, instead of X bar values, these are the range values. And in range value, if I represent here, I will be getting the central line R bar. This is going to be the solid line R bar. That is the central line of R chart. This is R bar. And upper control limit. Here the upper control limit is 3853 and the central line is 0.169. This is 0.169. And the upper control limit, it is 0.3853. UCLR, this is equal to 0.3853. And the lower control limit is, it coincides with 0. Is it understood? The same thing applies to this one. As long as it falls on this line or within this, okay, fine. There is no difference at all. It is, the process is under control. Try to understand. One point, it falls within the control limits on X bar chart, but the same sample, the point falls outside the control limit. What is the conclusion you are going to draw? One case. The another case might be, it might be falling within these things, range control limits, but on the X bar chart, it falls beyond the control limit. Then what? Or on both the charts, it has fallen outside the control limits. These are the three possible things what one can envisage. Got this one? The same sample, its range values, they will fall outside one of the control limits, outside one of the control limits. Okay. Similarly, on X bar chart also it falls outside the control limit. What is to be done? Or it falls within the control limit on X bar chart. It falls outside the control limit on R chart. Or another ways, it will fall within the control limit on R chart, but it falls outside the control limit on X bar chart. In all these three cases, the process is, we have to conclude that the process is out of control and the investigations are to be made. If we say that it is not falling within the control limits on X bar chart, means what? Its process average is shifted. It is no longer within that variation, within that process average, whatever we expected it to vary, no longer it is doing like that. It is changed. Okay? That is why the process needs to be stopped and investigations are to be made. And if it falls outside the control limit on range chart or the sigma chart, what does it mean? It might fall within the control limit on X bar chart. Okay, fine. That means the process average is not changed. It is within the expected norms. But since it has fallen outside the control limit on R chart, its variation is not within the expected limits. So the spread is increasing, it is changed. Okay. Hence, the process is to be stopped and investigations are to be made. Okay, at this juncture, I want to bring upon two things. Because this problem it is solved, but I am going to bring in certain other concepts. Now we said the process is under control or not control. Okay, fine. That is what I told you. But here, our thing was limited to only finding out these things, estimating these things. That is what we have estimated and we have established. And other thing is to be found out. Whatever the other thing he has asked in this particular case is, what is sigma prime or the process average? That is what he has said. 3 sigma limits, and because he said compute the values of 3 sigma limits for X bar and R charts and estimate the value of sigma prime. What is this sigma prime? Sigma prime is the process variation or the standard deviation of the process. It is not the standard deviation of the control chart. Standard deviation of control chart is sigma x bar. Okay. The process variation sigma prime is different. Which is more, whether the control chart sigma x bar is more or sigma prime is more? Because we have seen, that is how we have estimated even this one sigma x bar, because we know that sigma x bar is equal to sigma prime divided by square root of n. So always the sigma x bar is less than sigma prime. Sigma x bar is equal to sigma prime only when the sample size is 1. The moment if it is more than 1, sigma x bar is going to be less. And already I told you, to maintain, or because of central limit theorem, we should not collect the sample less than 4. Okay? So naturally, sigma x bar is going to be lesser than sigma prime. Okay, it has got a lot of significance, this sigma prime. Maybe in subsequent class or subsequent example, now I am going to take subsequent example, we'll try to find out that one. Now, only the sigma prime, how it is to be estimated, that is what I am talking about. Since we know sigma x bar, and sigma x bar itself was calculated by how? By calculating sigma prime. How the sigma prime was calculated? Sigma prime was calculated, we know that sigma prime is equal to R bar by D2, where D2 is the factor which will depend on the number of samples or the subgroup size. This D2 itself was calculated, it was from the tabulation, this D2 was found out. This D2 for n is equal to 4, it was found out to be 2.059. Either this value is to be referred to the C table of the given statistical tables, or it should have been given. It depends only, I can say that it depends on the sample size, it is not. Hence, this, we know R bar, we know D2, hence sigma prime is calculated, and it is calculated as 0.082. Next thing comes into our mind is this sigma prime, if I want to calculate, I should satisfy certain conditions. If the control chart, whatever is there, when control chart is, or the process is there going on, first we need to establish that the process is under control. Then only I can find out the sigma prime. That means we will establish the control limits and plot the values of the values which are used to find out the control limits itself. And if all the values they fall within the control limits on X bar as well as R chart, then only I say that the process is under control. If the process, all the values they fall within the control limits, then only I will proceed to find out sigma prime. So in this particular numerical example, it is already mentioned. What is mentioned? Compute the values of 3 sigma limits for the X bar and R charts and estimate the value of sigma prime. He has not stopped only at estimate the value of sigma prime on the assumption that the process is in statistical control. Since he has mentioned, I can find out. If he had not mentioned, I cannot find out here. Because the individual values of this X bar or X values are not given. Only the cumulative values are given. Sigma X bar is given based on which one I have established. So, but when we start establishing the control charts, we will find out this particular part of problem, and then we will see in the subsequent examples how to do that one. Okay? Is it understood? Now, if it is understood, this is the case. Sigma prime we can find out, and that is how we have found out. Now, I was talking about this X bar chart and R chart. And I told you I am going to bring in some new terminologies in this statistical quality control, or sometimes it is called as statistical process control. And in a way, since these statistics are being applied in manufacturing sectors, so we are studying these things under the topic, the statistics for manufacturing. Okay? When the manufacturing thing is going on, how it can be applied. Okay, for that purpose, I will bring in 2 things. Okay? What are those things? Let me see. One is accuracy, another one is precision. In general, loosely, accuracy and precision both are being used in a synonymous ways. You think that both are same, but actually both are not same. Then what is meant by accuracy and what is meant by precision? Okay, that needs to be understood. Okay. Actually, precision means what? Precision, it talks about the variation or the spread. Okay, for this one, precision, it talks about the variation or the spread. And accuracy, it talks about the average value. Okay, that means here I need to find out range or standard deviation. That is what usually we are going to use. Here we are going to find out the arithmetic mean. Okay, that means there are various combinations of these things we can talk about. One is, and let us see how to represent them. Maybe taking some example. Because once it becomes more clearer, then the interpretation of the control chart or the process, it becomes easier. Try to think that ultimately what is our objective? Application of these statistics in the manufacturing. Now I want to see that whatever the manufacturing process is going on, whether I should allow it to continue so that no more defectives will be manufactured, or if I continue this one, it is going to produce some defective items. I should stop. This is which is the time it should be stopped and investigations are to be made. So that in a nutshell, I want that no defective products should be produced at all. This is why always we say that prevention is better than cure. Okay, that prevention has to be taken care of, and that is being applied in the present condition. That is what we can see, this community diseases like corona or whatever it is, what is happening. Okay, preventive means preventive steps are to be taken. What we are trying to do now, they are busy in finding out the vaccination for this dreaded disease. Okay, and in the process, while the process is there, it is being corrected. That means the patients are being treated. Some preventive actions, they say that best preventive action should have been finding that vaccination. Otherwise also we are taking some preventive actions in the sense, what are the possible causes of spreading of this corona disease? They are identified. If too many people, if they gather together, there is more chance. So limit that. And it can spread. How? That way they have identified. So always they say that frequently you should wash your hands, because these are the preventive things. Frequently it should be washed with the water at least for 20 seconds with the soap. And use the hand gloves. Okay, use the sanitizer. Keep oneself cleaned. Like that the government has released the number of guidelines for that. So that if these cares are taken, preventive measures are taken, then the disease will be under control. Okay. And the best controlling is to eliminate it itself, or see that, no elimination in the sense, see that it doesn't recur. In that case, ultimate aim is to finding out the vaccination. Okay, coming back to this one, okay, that is what I told you. Accuracy, variation, or the precision means it refers to variation or the spread. A process may be more accurate, but it is not precise. So what are the possible these things? I will list. One is process. This is what I will write at the top, because that is what I told you. When we talk about the probability or whatever the statistics, we should be able to delineate in the all the possible cases, all the possible ways. The first one is, it is the process is accurate but not precise. Second, process is not accurate but it is precise. Third, it is neither accurate nor precise. Fourth, it is both accurate and precise. For this one, so these are the four possible cases. Which one is good? So these are the four cases or four type of objective questions. Which is the one you are going to select? Okay, that's what let us see. Of course, we want the process should be accurate and precise. This is what we want. But without knowing what we mean by accuracy, what we mean by precise, because so far loosely we'll be using them as a synonymous. Both accurate and precise means both are same, but in statistical way it is not that. So that is what we are trying to understand that. So let us take accurate but not precise with the help of one example. Suppose two people, because usually if it is to be understood, I can take the example of cricket. That is what I was trying to give you, the example yesterday, consistency, because in place of precise, I was telling the consistency, and another way, average value I was talking about. But if I talk in terms of statistics, I should talk like accuracy and precision. Okay. Now here I am going to use what is this thing for shooting. For shooting practices and other things, what they will use is the bull's eye. Okay. That means there is going to be a board wherein there is a central, exactly middle, there is a center point which is called as the bull's eye. Okay. And around this one there are different bands. Like this. When a person shoots, he has to shoot within that diameter of the bolt. If it passes away from this one, it is going to hit, he may not be considered at all. So now what are the possible cases? It may be within this, okay? It may hit accurately like this, exactly at this point. But usually what happens? Somebody has hit like this. One, two, three, 4, 5, 6, 7, 8, 9, 10. 10 points, he has hit like this. Okay, 10 points. Another fellow, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He has done like this. What conclusions you will draw? Who is good? Who to draw? Because for sake of simplicity, what I will do, I will try to measure only in the horizontal direction, because it can be measured in vertical direction as well. But for this case, I am trying to make it horizontal dimension, that means from here, because this is the central value. With respect to this one, whether it is on positive side or negative side, that is what I am going to find out. What this one? So this distance I will measure, this distance, like that. I will go on measuring from with respect to this. What is that? I am going to find out. And their average values. That is what we have to find out, is it? Okay. Then we will find out that their average value, its average value will be where, if I find out the distance, if I measure, where I will find out the average value is somewhere here. Whereas the average value should have been here, now the average value is here. And if you look at its spread, it has got the variation only from here to here. That means if I represent this thing, it might be like this. You just see. What this one? Now what has happened here? The average should have been here, the average is shifted to this. What about this variation? It is so much, spread is so much. You look at this one. Here its average, I wanted it to be here, exactly it is here only. There you find out the average. But its spread, it is going to be like this. It has got more spread. It is varying from this one to this one. From here to here it is varying. Whereas its spread is only this much, small. So I can say that this is precise but not accurate. What this one now? This is precise, not accurate. This is accurate but not precise. But what I want? What I want is accurate and precise. In some cases, it might be something, it has gone out of way here and other things. In that case, we can say not accurate. This is what? Accurate but not precise. Not accurate but it's precise. That is what we have seen from here. Neither accurate nor precise. Random, because something will go out of this one. No, it doesn't have any meaning in that. So it is to be overruled. So the most preferred thing is like this. So I need to find out, this is more precise. That means he has got, this fellow, he has got the certain tendency. That means it is biased at the left. Maybe his pistol or whatever it is, rifle, if it is, instead of putting it slightly on the left side of the targeted mark, if he shifts it towards the right, it will become more accurate as well as precise. So, compared to this fellow is much better. Okay, compared to this one, this fellow is much better because it can be easily trained. Whereas here training of this person becomes a bit difficult. Okay, because something will go here, something will go there, but it has to be the precision. That is what one is aiming at as a coach. They will try to correct these things very easily. This one, it requires again some rigorous practice. Okay, that is what is to be understood. Okay, and we want in this way. So we learn from this one that it is what is meant by precise and what is meant by accuracy. Here, mostly in SQC, statistical quality control, its precision, it is inbuilt, that is what we accept. Variability is going to be there. We cannot improve upon it. That is what we say. That is what, variability for this person is so much. Variability, this thing, it is going to remain there. That is what we assume in this case. Precision cannot be changed easily, whereas accuracy can be changed. That shifting the average value can be changed very easily. This is what I told you. Here, shifting of this average value, it can be done very easily just by shifting this middle value. That rifle, if he is slightly moved on the other side, yes, that fellow will become more accurate as well as precise. So, shifting of average value is very easy and changing of the precision difficult. Okay. So, in technical terms, changing of precision means changing of the person itself, changing of the machineries itself. Instead of using the old machine, now I will try to use the new machine. Instead of the less skilled, I have to appoint a more skilled person. Instead of the one process, say for example, maybe lathe machine may not be adequate. In addition to lathe machine, I need to use the grinding operation. So that means precision can be increased. I don't talk about accuracy, but precision. That is what I am talking about. So, changing of process is called for when the precision is at stake. Okay? But it will become a costly affair. Where changing of accuracy, it will not become a costly affair. With certain minor changes, we can achieve it. That is the crux of this statistical quality control. It will tell us what we should do. Whether it will say that because these are certain uses, that is what at the end of this particular unit we are going to list down. That is why I never listed down what are the uses or what are the benefits of the control charts. Because in between we will go on talking about like this, and finally we can put it in writing at the end of this particular unit. Okay, that is what is to be understood. Okay, so we know about accuracy and precision cannot be easily dealt, whereas accuracy can be easily dealt, and that is what is being used. Okay, now let me take some more numericals so that we will understand it in a better way. Take okay, we'll take up this example. Determine the control limits or it is same as the previous, but it will give you some, it gives some it throws some light. Determine the control limits for X bar and R charts if sigma X bar is 357.60 units. 357.50 units. And sigma R is equal to 9.90. Number of subgroups 20. Number of subgroups 20, that is M is equal to 20. It is given that A2 is equal to 0.18, A2 is equal to 0.18, D3 is equal to 0.41, D4 is equal to 1.59, and D2 is equal to 3.735. So here we need not have to refer the table, all the given values, all the values are given. But here you can observe that they are never mentioned about the sample size. If we had given the sample size, I would have referred the table and I would have found out these values. Okay, that is what would have been done. Okay. Now, since he has given the values, it becomes much more easier for us. Only thing is, we should know what are the relationships. That is all. Now we know that because what he wants, control limits for X bar chart and R chart. So the control upper, that means upper control limit, central line for X bar chart, lower control limit for X bar chart, upper control limit for R chart, central line for R chart, lower control limit for R chart. Here it is R bar. Here it is D4 into R bar. Here it is D3 into R bar. Here it is X double bar. And here it is upper control limit for X bar is equal to X double bar plus A2 R bar. And lower control limit of X bar chart is X double bar minus A2 R bar. And in addition to this one, I need to find out process capability. Now, he has brought in the new word. Also find the process capability. That is the reason why I have selected this particular numerical. Okay. Otherwise, there won't be much difference between this numerical and the previous numerical. There also all the values were given, only instead of A2 and other things, the sample size was given, so we could find out that one referring through the table. Here, the X double bar, it is known in the sense that is equal to sigma X bar divided by 20, this is equal to 357.50 divided by 20, and R bar is equal to 9.9 divided by 20, and it works out to be 17.875, and R bar, it works out to be 0.495. Okay. So hence the upper control limit A2, these things are given, these values are given by multiplying the corresponding elements. We are going to get these total values I am going to mention over here. Total value is going to be 17.9641. 17.9641, that is the upper control limit of X bar chart. Central line of X bar chart is 17.875. And lower control limit for X bar chart is 17.7859. And upper control limit for R chart is D4R bar, that is 0.878705. And this one, CLR, central limit of R chart, that is equal to R bar, that is 4.495. Lower control limit of R chart is 0.20295. These are the things we can get. Okay, all the things have been found out. Upper control limits, lower control limits, and central line for the respective charts, namely X bar chart and the R chart. Only thing is, now I need to find out what is process capability. Okay? The process capability is nothing but, because if we assume that these all things, they will follow the natural process or the normal, if they are normal process, that means they follow the normal distribution or Gaussian distribution. That means always it will follow like this. It is a bell shape. The spread might be more or less or whatever it is, let us not bother about that. But this thing, process capability, that is what I told you. It talks about the precision. That means it talks about its spread. If we think that this is the central value, targeted value, how much spread is there? This one it talks about. What is the spread? This is going to be the spread, natural spread. Some process may have like this, some process may have like this, some process may have like this. We just try to see. Compared to this one, this is better. Compared to this, this is better. Still better would be this one. So I should go on increasing that one. That is, whatever I have shown might be a bit wrong. Or if I depict it on the same this thing, it can be like this, because that area has to remain same. If it is like this, because the total points following this will be more around this, or still much better like this. So that means their spread, it is going to be lesser, 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 like that, which is preferred. Ultimately, it falls on this targeted value or the average value accurate. That means it is more precise as well as highly accurate, or on the target. That is what Japanese they say, zero defect, no deviations. From what? From the average value. That means we should be able to design the process in such a way that it is accurate as well as precise in anything. Because sometimes you might hear in the class, try to be precise, don't beat around the bush. The same thing. Because if I am not knowing the things, we'll try to waver here. This is nothing but wavering. It shouldn't be. But it has got some natural tendency. That is what is called as process capability. What is its natural variation? So this one we can say that this variation I can take up to 3 sigma limit. So this is the mean value. This side it is sigma, 3 sigma. Another side also it is 3 sigma. This is mean. This 3 sigma it is on the left side. That means the variation from here if I take this is mu minus 3 sigma. And if I go to this one, this will become mu plus 3 sigma. What is the difference between these two? That is the spread I want to find out. Okay? What is the difference? That is mu plus 3 sigma. Because this side it increases, this side, the left side, the value decreases. So 3 plus mu plus 3 sigma minus mu minus 3 sigma. That range I am trying to find out. Okay? If I remove the bracket, this is mu plus 3 sigma minus mu plus 3 sigma. So the mu gets cancelled. So what I'm left with is 6 sigma. Or I can say prime, whatever it is. So this spread is called as the process capability. 6 sigma prime is nothing but the process capability. That means we need to find out sigma prime. And again, I emphasize sigma prime can be found out only when the process is under control. And here these values, process capability can be found out if he has not mentioned that, but we'll assume that all the values of the process is under control. We will make that statement and then I will proceed. Go ahead with finding sigma prime. What this one? It is not mentioned here. Just he says, also find the process capability. But assuming that is what he had mentioned in the previous, okay, previous example, that is what he has mentioned. On the assumption that the process is in statistical control. Find out the process capability on the assumption that